Hi everybody, my name's Angela Keyworth and thank you for joining me for this retrofit overview. This is a short session on an introduction to retrofit, and during this session we'll be covering first of all who are we as Simply Group, that's Simply Certification and Simply Learning. What is retrofit? What's all the buzz about? Exploring different roles in retrofit. Overview of schemes and standards. We're going to try and decode the retrofit terminology, or certainly some of the more popular things that you will hear. There's nothing we like more than a good acronym in this industry. And we'll have a look at a short video from the Ashton Group on a whole house retrofit and the process. Firstly, who are we? Simply R&R, Retrofit and Renewables. Well, we're made up of two companies, Simply Certification and Simply Learning. And we both provide services to support organisations and individuals on the pathway to access the UK supply chain for retrofit and renewable contracts, but also funded works. Simply Certification deliver assessments for organisations so they can gain recognised certifications such as PAS 2030 for installers, MCS, Microgeneration Certification Scheme, FlexiOrb and Trustmark. Simply Learning deliver training and qualifications for individuals so that they can meet individual competency requirements that organisations need their people to have in order for them to meet those standards. In terms of content and courses, we have a variety of different subject matters and also delivery styles. So we can train health and safety all the way through to retrofit renewables, but also practical courses like plant and confined spaces, heat pump installation, construction and utilities. We can offer various delivery methods. We can do classroom-based training at our site. We can do practical training, remote tutor-led training, online self-paced learning. We can come to your site and deliver training, and we can also offer you privately closed courses or open courses. So what is retrofit? Retrofitting is the process of making an existing building more energy efficient but also more eco-friendly. It involves upgrading a building system such as insulation, heating and lighting to reduce carbon emissions and to improve sustainability. So retrofitting is becoming increasingly popular due to changes in regulations aimed at reducing carbon emissions. So it's about upgrading the UK housing stock. It's to cut carbon emissions and to make homes warmer, but also more importantly cheaper for occupants to run. Homes that are in a state of disrepair can be responsible for higher CO2 emissions, but also various health conditions for the occupants within them. There are approximately 27.5 million homes in the UK, and out of those, approximately 24 million could benefit from whole house retrofit, making the homes low carbon, low energy, and reducing the impact of climate change. So if we're going to talk about retrofit, we've got to talk about PAS. What is PAS? Well, it stands for Publicly Available Specification. And there are many variations of publicly available specification. It's not specific to retrofit. What makes it specific to retrofit is the number that precedes the PAS. In this example, 2035. And the PAS 2035 is the specification for whole house retrofit. It was launched on the 1st of January 2020, and it covers how to assess dwellings for retrofit, but also identifying improvement options, designing and specifying energy efficiency measures and monitoring retrofit projects. It was introduced initially with the support industry and the backing of the Government Department for Business, Energy and Industrial Strategy. You may also have heard that as BEIS, B-E-I-S. So where did it all start? In 2015, the government commissioned the Each Home Counts review, and that was to determine ways of improving the confidence of both government and consumers in the domestic retrofit industry. But it was also about improving the quality of retrofit work. So the report of the review that was published in December 2016 contained 27 recommendations. One of those recommendations included the establishment of a quality mark for any domestic retrofit activity, and that would be supported by an industry code of conduct, a consumer charter, and a framework of technical standards for retrofit. That quality mark has subsequently been established as the Trustmark government-endorsed quality scheme. So the British government made a pledge to reduce carbon emissions by 80% by the year 2050. And CO2 levels are the highest that have ever been recorded. Climate change is unequivocally happening, and that rapid increase is linked to you and me, human activity. We have to implement some very serious measures in the next few years, not to reduce emissions, but to simply maintain them. Unfortunately, we've gone too far. We can't reduce emissions now, but we have to maintain them at the levels they currently are. The next driver is the Kyoto Protocol. This was a protocol to the United Nations Framework Convention on Climate Change. It was a very important first step towards a truly global emission reduction regime that would stabilise greenhouse gas emissions. And it set binding obligations on the industrialised countries to reduce the emissions of greenhouse gas. This protocol was adopted in Kyoto, in Japan, on the 11th of December 1997, but it entered into force on the 16th of February 2005. And then we have the Climate Change Act. And this was the UK. We passed the first legislation that introduced the world's first long-term legally binding framework to tackle the dangers of climate change. This was introduced in 2008, and it created a new approach to managing and responding to climate change in the UK. It did that a few ways. Firstly, by setting some ambitious and very stringent legally binding targets. But it also strengthened the institutional framework, which enhanced the UK's ability to adapt to the impact of climate change. The UK has set the most ambitious target to reduce climate emissions by 68% by the year 2030. And that's compared to 1990 levels. It's the only major economy to have set a target of 77% by the year 2035. Previously, we had some targets. These are now the old targets. We've now the government set some new targets in place. And the targets were as follows. Ban the sale of new petrol and diesel cars by the year 2030. Phase out the installation of off-gas grid fuel boilers. LPG, oil and coal, and that was from 2026. To phase out fossil fuel boilers and introduce heat pumps by 2035. To force landlords to upgrade the efficiency of the properties by the year 2030. And to cap the boiler upgrade grant at $3,750 for those converting to heat pumps. But we have new ambitions now. These have been amended and updated. So the UK, irrelevant and irrespective of those updates, will still remain the country with the most ambitious, stringent decarbonisation targets in the world, even after the changes have been made. So what do those changes look like? So let's take a look at the new ambitions, the new targets. To move back the ban on the sale of new petrol and diesel cars by 5 years. Originally, the ban stipulated no more sales of diesel and petrol cars by 2030, so all sales of new cars from 2035 will be zero emission. This will enable families to take advantage of falling prices for new technology over the forthcoming decade if they wish to. Delay the ban on installing oil and LPG boilers and new coal heating for off-gas grid homes to 2035, instead of phasing them out from 2026. Many of these homes are not suitable for heat pump, so it ensures that homeowners aren't having to spend around $10,000 to $15,000 on upgrading their homes in just 3 years' time. Set an exemption to the phase out of fossil fuel boilers, including gas, in 2035, so that households who will most struggle to make the switch to heat pumps or other low carbon alternatives won't have to do so. This is expected to cover about a fifth of homes, including off-gas grid homes, those that will need expensive retrofitting or very large electricity connection. Scrap policies to force landlords to upgrade the energy efficiency of the properties, but instead continue to encourage households to do so where they can. Raise the boiler upgrade grant by 50% to £7,500. That's to help households who want to replace the gas boilers with a low carbon alternative, like a heat pump. So we're going to take a look at an overview of schemes and standards. What standards are currently in place to make sure or to ensure compliance? There's PAS 2035, Whole House Retrofit Standard. PAS 2030, this refers to the installer standard. MCS, this is Microgeneration Certification Scheme. This is the standard for renewable technology. We now have recently introduced FlexiOrb. This is also a renewable standard. And we have PAS 2038, and that refers to non-domestic retrofit. So we're going to take a look at these in more detail over the next few slides. So, PAS 2035, Whole House Retrofit. Let's take a look at a 5-step guide to navigate that journey. First of all, identify. Set out key building information, constraints, risks and opportunities. What properties, what demographic is suitable for a retrofit upgrade programme? Assessment. Measure the existing performance of the property, make sure we understand where the baseline is, understand existing usage, occupancy, defects and current levels of ventilation. EAMS, Energy Efficiency Measures. A home's made up of many elements, including how it was built, how it has been adapted, what materials were used and how the building is currently being used now. The way in which these elements are connected and how any new measures might impact them needs to be considered in a very comprehensive and logical way. Buildings function as a whole structure, very sensitive to changes that happen within them. So planning measures in isolation rather than as part of a joined up process, setting off unintended chain reactions. This is likely to cost more money or mean that you don't improve energy efficiency much at all in the long run. Design. You shouldn't think about measures in isolation. If you've got several measures you want to install, you need to decide on a logical order. Sometimes it won't make much difference, but in many cases it probably will. You've got to think about whether installing one measure will make another harder or undo some of the work that's involved. One example, for example, is external wall insulation and replacing the windows. If you want to do both, you should do the windows first. If you do the external wall insulation first, there's a risk it'll be damaged when the old windows are taken out and replaced. Similarly, if you're considering a new heating system, significant new insulation measures, you've got to do the latter first. Otherwise, your heating system is likely to be oversized once your insulation measures have been installed. The other situation where measures can impact each other is when two or more measures are cost effective when installed together. For example, scaffolding is expensive to erect, and if you've some solid wall insulation, then you could think about solar panels at the same time. Finally, we have evaluation. Retrofit projects are large investments. It's important to monitor that they delivered results for landlords, for funders and for residents. Monitoring and evaluation are essential to any retrofit project or programme. It's only this process that we can collect and analyse data and determine if a project or a programme's fulfilled its goals. Monitoring begins right away and extends through the duration of the project. Evaluation comes after and assesses how well that programme has performed. So PAS is applied to all funded domestic retrofit work, and that includes work that's initiated, procured and funded and delivered in a very wide variety of ways. And they include Programmes funded by national or local government schemes. Landlords funded by landlords, including social housing organisations and private landlords in the domestic sector. Retrofit of individual buildings by the owners or the occupants. And retrofit that's been integrated with and forms part of broader repairs, maintenance and improvements. When we consider domestic retrofit projects, the PAS 2035 and the PAS 2030-2019 are effectively locked together, and that's very simply because one standard cannot be used without the other one. The only exception to that is the installation of some measures in accordance with the MCS standard rather than the 2030 where specified, and that's because the MCS standard microgeneration certification scheme is a standalone standard for renewable technology. When we talk about retrofit, all properties are assessed as having a risk pathway. Those risk pathways are A, B or C. The process of assessing for a risk pathway is the responsibility of the retrofit coordinator. A retrofit coordinator will complete a risk assessment, and it's a desktop exercise. It does not require a site visit. If a property or a project is deemed a risk pathway A, this is considered the lowest risk property. It could be assessed on site, and it can be assessed by the coordinator or the retrofit assessor. Risk Path B is a medium risk due to a combination of property and measure risks. So these properties can be only assessed by a retrofit assessor. And then we have a Risk Pathway C. Risk Pathway C represents the highest risk buildings. These could be listed, protected, high-rise buildings or large-scale projects within technical risk measures. This can only be assessed by a qualified retrofit assessor. The PAS 2035 is changing. The latest version of PAS 2035 was released in September 2023, and it introduced a few notable changes. First of all, there's more emphasis that's been placed on whole dwelling retrofit rather than the installation of measures in isolation. The standard now references appointing a main contractor to oversee the project. The retrofit design process can commence earlier in large-scale programmes based on an assessment of archetypes or dwelling types before every home is surveyed. The requirements for providing retrofit advice to occupants before, during and after the works has been strengthened. The guidance around ventilation has been updated following revisions to building regulations. Risk assessment requirements have been simplified to avoid unnecessary complexity. More focus has been placed on monitoring retrofit outcomes and feedback to improve quality. New allowances have been put in place for a distressed installation such as urgent boiler replacements. And the consideration of climate resilience, flood risk and overheating has also been enhanced. So retrofit assessors. The criteria has been updated in line with the number of measures, but the approach remains the same. In terms of retrofit coordinators, the criteria has been updated in line with the number of measures approach, but again remains the same. Retrofit designer. Criteria has been updated in line with the number of measures approach. Only a suitable, qualified retrofit designer can now undertake that task. It no longer includes the retrofit coordinator as previously allowed under PASCs A and B. Responsibility for design rests with the specialist designer and not with the retrofit coordinator as previous. Qualification criteria for the number of measures and where properties of traditional construction have been amended and expanded to include additional options and requirements. So let's take a look at the different roles within the PAS 2035 process, because as we've already alluded to, there are more than just one role. Let's start with the Retrofit Advisor. The Retrofit Advisor is often the first initial contact with a customer. The advisor serves as a critical link amongst all parties involved in the retrofit process. That includes residents, assessors, coordinators, designers and installers. The responsibility of the advisor encompasses both technical guidance and administrative support, helping to ensure the retrofit journey is seamless for everyone involved. Then we look at the Retrofit Assessor. A retrofit assessor is a qualified professional responsible for evaluating existing buildings to identify opportunities for energy efficiency improvements and sustainable upgrades. They assess various aspects of a building, including its insulation, its heating system, ventilation, and overall energy usage, and that's to provide recommendations for retrofits that can enhance energy performance and reduce carbon emissions. A retrofit designer, often an architect or a technologist, is tasked with the intricate challenge of integrating contemporary materials, products and technologies into established structures. This role isn't only about enhancing a building's energy performance, but it's also about meticulously planning to mitigate risks during that installation process. The retrofit evaluator oversees the final project and has the skills and the knowledge to understand why a project may or may not have delivered the expected outcome. Evaluators are generally kept separate from coordinators to ensure a transparent view of the full project. And finally, within the 2035 specification, we have a retrofit coordinator. And a retrofit coordinator is the project manager for the whole retrofit project. They approve the retrofit assessment findings, they develop a project plan, and they manage the installation works. They are responsible for claiming compliance with the PAS 2035 standard, but they are also responsible for the entire project. Now, the only role that we've left out that's on this slide is the retrofit installer. And the reason for that is because the retrofit installer is accredited and certified independently under the PAS 2030 standard. They are not part of the 2035 standard, although they work hand in hand and are integral to the project under whole house retrofit. They are certified independently under 2030. So here you can see how the 5 roles work together. We've got 6 roles within retrofit, 5 key roles in retrofit 2035. Installer, again, certified independently under PAS 2030, which is the standard for all installations under retrofit. So the 5 roles in here, we've got the advisor, the assessor, the evaluator, designer and coordinator. So let's take a look at these roles. The retrofit advisor. Advice on retrofit should be delivered on initial engagement of a household commencing a project, but the advice could be delivered in person, it could be by telephone, could be by website, or it could be in a printed form, or maybe even a combination of both of those things. In all cases, the advice should be delivered independently of the PAS 2030 retrofit installer so that the integrity of the advice is not compromised by bias. Okay, so retrofit assessor. These people are qualified to carry out the on-site retrofit assessment, the whole house assessment, and that means they must firstly be qualified as a domestic energy assessor. That includes a condition and ventilation assessment, the RDSAP data file, which if you're not familiar with that, stands for Reduced Data Standard Assessment Procedure data file. That's the file and the software that energy assessors use when completing an energy performance certificate or an EPC. They also have to complete an occupancy assessment and provide photo evidence and defects of the property in the form of a report. So the retrofit designer is responsible for preparing, designing and specifying information about the energy efficiency measures or the package of energy efficiency measures for the property. And that includes things like materials, products and processes and standards as appropriate. So they have to take into account the condition of the existing building, the agreed scope of the project and the intended outcomes, and also any agreed performance targets for the property and the budget. They will also look at the information in the report from the assessment done by the retrofit assessment and conditions imposed by the local planning authority or the building control body as part of a statutory approval. Every retrofit project is subject to monitoring and evaluation, and that's to determine whether the intended outcomes of retrofit have been realised. So they also need to identify, very important to evaluate every project so we can learn from any project-specific or systematic problems with the risk assessment, the dwelling assessment, the retrofit design, the installation of measures, or the testing, commissioning and handover of energy efficiency measures. And then we have the retrofit coordinator, which, as we've already established, is the overarching responsibility for the retrofit project. So every project compliant with the PAS 2035 standard must be coordinated by a retrofit coordinator. And the retrofit coordinator is qualified to provide that end-to-end project coordination from the inception of retrofit to handover and beyond. So we mentioned earlier about the PAS 2030 standard. That's the PAS 2030-2019 standard. This is the installer standard, which is currently being used. And the 2030 has 25 measures. It covers 3 primary types of installation. It covers building fabric measures, building services mechanical, and building services electrical. So we're going to take a look at each of those 3 areas in more detail. So fabric measures. Fabric retrofit measures aim to improve the building insulation performance of an element and restrict any uncontrolled air movement. Now you can either modify the element, for example, window draft proofing or making window shutters operational, or you can introduce new insulating materials within the building element itself. For each building part, there may be various ways of achieving improvements of performance, depending on the building's specific context that can be explored. For example, floors may be solid or suspended, and floor insulation can be added above, within, or below the existing floor structure. The next measure we consider are mechanical measures in PAS 2030. It's only when we've satisfied the appropriate fabric upgrades to thermally improve the building's heat loss envelope that we should consider installing or upgrading mechanical measures. For example, boiler upgrades, underfloor heating, hot water systems and heating controls. Within the fabric first measures, it's pointless to skip this next step. And finally, we have electrical measures. And these include upgrading storage heaters, potentially to high heat retention heaters, and retrofit all lighting outlets with low energy lighting. So we've talked about the Microgeneration Certification Scheme, or the MCS scheme. Well, the primary objective behind the MCS's inception was to foster sort of a consumer confidence in renewable energy technology. It aimed to ensure that investments in renewable energy weren't just environmentally sound, but also technically robust and reliable. So it's commonly known as MCS. More than just a certification, it's the seal of quality assurance. So what's it all about? Well, originating in the UK, the MCS has been instrumental in setting benchmarks for the renewable energy industry. And it assesses both the products, like the solar panels, wind turbines, the installers, ensuring they meet the consistent standards of quality and competence. In essence, the MCS certificate acts as a bridge between consumers looking for reliable renewable energy solutions, and providers committed to delivering quality. It's a mutual assurance pact, so it ensures that the technology is not just sustainable in the environmental sense, but also terms of longevity, performance, but also value for money. So the MCS covers the installation of 8 low and zero carbon technologies, and just 3 of those technologies are solar PV, solar thermal and air source heat pumps. So let's take a look at the process for a solar PV system, for example. Very simply, how do PV work? What does the measure? What does it involve? Well, you've got the solar panels that convert light energy from the sun and turn it into electricity. You've got the inverters. We consider battery storage. You must consider orientation when installing solar panels, ideally a south or southwest orientation. We look at the designs for peak output, so look at shading diagrams. Designs have got to be completed to provide predicted real-term energy production, known as peak power. We have to consider the structure that the solar panels are going to be fitted or proposed for. So we have to do an assessment to make sure it's robust, to make sure that the roof is structurally sound to be able to take the weight of solar panels. The installer must have that relevant competency to design and install under Annex A of Solar PV Install Standard. And the contractor must also register the installation on the MCS installer database. Let's take a look at heat pumps. Heat pumps absorb heat from the external air. They use the ambient temperature, and it's that heat that's used to heat the water in the system for heating and hot water. Very effective for underfloor heating. If fitted in the correct property and that the existing building service efficiency has been increased, then low and zero carbon technology like MCS heat pumps can make a significant contribution to the energy efficiency for the property. And heat pumps can result in up to 300% more efficiency than a conventional gas boiler. Let's take a look at FlexiOrb. FlexiOrb stands for Flexible Energy Oversight Registration Body. And Simply Certification were the first certification scheme to be awarded with this high certification. What's it all about? Well, FlexiOrb is an installation standard scheme for renewable technology. It's the first scheme of its kind to be recognised by UCAS to the ISO IEC 17067 2013 standard. And that standard describes the fundamentals of product certification and provides guidelines for understanding, developing, operating or maintaining certification schemes for products, processes and services. FlexiOrb installers are certified to carry out and register solar photovoltaic or PV, electrical energy storage systems EESS, electrical vehicle charging points EVCP installation, and in addition to that, FlexiOrb are currently working on adding heat pumps to the scheme, and installers will be able to become certified to install that technology next year in 2025. The next standard we're going to talk about is the PAS 2038-2021. This specification is outlining retrofitting of non-domestic buildings for improved energy efficiency. Non-domestic buildings undergo retrofit for a variety of reasons, and the objections mentioned previously are rarely the sole purpose of this kind of project. Often retrofit is combined with repairs, maintenance and improvement, but also alteration, extension, change of use or change of tenancy. Sometimes the overall objective is to maintain or improve a business commercial value by making it more attractive to potential tenants or purchasers, or it could be to the occupants or the customers. For the purpose of this specification, retrofit projects are divided into 4 broad categories. Retrofit of an owner-occupied building, often but not always including both the building fabric and the building services. 2. Retrofit of a tenanted building between tenancies, for example, when unoccupied. Again, often but not always, including both the building fabric and the building services. 3. Retrofit of a tenanted building, embracing only the building envelope or the common parts, and the building services provided by the landlord, also referred to as retrofit of the base building. And 4. Retrofit of only the parts of a tenanted building that are occupied by a tenant, including any services, for example lighting, that the tenant provides, sometimes referred to as fitting out or refitting. What's the purpose of PAS 2038? Well, the purpose of the PAS 2038 is to provide building owners, occupiers and energy managers and any other kind of stakeholder involved in the build with a standard for retrofitting energy efficiency measures in a non-domestic building. It follows the whole building retrofit approach, which will ultimately improve the energy efficiency of our existing builds, working towards the UK's commitment of reducing carbon emissions. When the PAS 2038 retrofit is completed, it will improve comfort, well-being and the health of the occupants, improve the functionality, viability and durability of the build, protect and enhance the architectural and cultural heritage of a build, and it should reduce the environmental impact of the build as well. Non-domestic buildings accommodate a huge variety of activities and range in size from simple corner shops to large multi-storey mixed-use buildings, shopping centres, also hospitals and even universities. Some buildings are owner-occupied whilst others are let to single tenants or accommodate multiple tenants. Some buildings are managed and maintained by the occupants who may have little knowledge of buildings or how to improve them. But many are managed and maintained by building professionals, for example surveyors, commercial agents or facilities managers. The image in front of you illustrates the breakdown of non-domestic building stock in England and Wales by activities accommodated and by floor area. The 4 bulk classes of non-domestic buildings, which together constitute more than half the total floor area, are offices, shops and commercial services, factories and workshops, and warehouses and storage. The remainder of the stock is composed of buildings that have many other uses. So the PAS 2038 is for anyone involved in the funding, assessment, specification, design and installation of building improvement measures, including building and construction professionals such as architects, facilities managers, engineers, surveyors, site managers or architectural technologists, suppliers of the building materials and products. This specification will also be of interest to owners, developers, insurers and investors, even tenants and landlord bodies, local authorities and building control bodies, energy assessors and auditors. The PAS 2038-2021 covers all buildings except those used as private dwellings, so for example houses, bungalows, flats or apartments, including multi-residential buildings in which occupants share some communal facilities, so hotels, for example, guest houses, hostels and students or nurses accommodation. So the use of the PAS 2038 will support improved functionality, usability and durability of buildings, improve comfort, well-being, health and safety, including fire safety and productivity of building occupants and visitors, enabling buildings to use low or zero carbon energy supplies, improved energy efficiency, which will lead to reduced fuel usage, fuel costs and pollution, especially greenhouse gas emissions associated with energy use, reduced environmental impacts of buildings, protection and enhancement of the architectural and cultural heritage as represented by the building stock, avoidance of unintended consequences related to any of this, and minimalisation of the performance gap that occurs when reductions in fuel use, fuel costs and carbon dioxide emissions are not as large or intended as predicted. Now, if you have a smaller commercial building, the specification 2038 doesn't need to apply. It's possible to follow the 2035 standard, providing the building meets these requirements. So, space, it must have a floor area that does not exceed 500 metres square. The height shouldn't be more than 3 stories in height, which includes a basement. Construction, that it's constructed of load-bearing masonry walls, solid or cavity brickwork, blockwork or stone, or it's timber-framed and clad externally with brick or timber. Roofing has mostly pitched roofs with timber structure covered in slates or tiles. Building services has building services that consist of heating, hot water, ventilation, lighting and a small power supply, possibly supplemented by PV or solar thermal. So now we've taken a look at the roles and the standards within energy efficiency. Let's take a look at trying to decode the industry. There's nothing we love more than an acronym in this industry. So a few acronyms here. Air source heat pump, ASHP. ACH, air changes per hour. BRE, building research establishment. CWI, cavity wall insulation. CDM, condensation, damp and mould. CO2, carbon dioxide, greenhouse gas. CWI, cavity wall insulation. DCV, demand controlled ventilation. DEA, domestic energy assessor. ECO, energy company obligation. EPC, energy performance certificate. EWI, external wall insulation. FIT, feed-in tariff. Flexiorb, renewable technology scheme. GDA, Green Deal advisor. GSHP, ground source heat pump. HLP, heat loss perimeter. PAS, publicly available specification. The two that are concerning this presentation, predominantly 2035, which is whole house retrofit, 2030, the installer standard, and we've also covered 2038 for non-domestic buildings. PV, solar photovoltaic panels capable of providing electricity. MCS, microgeneration certification scheme. And a U value. What is a U value? The rate of heat loss through building elements, also referred to as thermal transmittance. So what is energy efficiency? Let's look at the basics. Some examples of retrofit. Retrofitting is huge within the construction industry, especially as developers are looking to become more eco-friendly. Retrofitting buildings helps to create builds that are more thermally efficient, more carbon efficient and sustainable in the long haul, helping to make the buildings we live in cheaper and to have less maintenance, hopefully. With around 2/3 of the current housing stock predicted to still be around in 2050, retrofitting is vital to help protect the planet and to meet the net zero 2050 plans that have been set by the government within the UK. Let's consider the thermal performance of a building. The thermal envelope of a building comprises all the parts of a building that are exposed to the outside air, or those parts that come into direct contact with the ground. That includes external walls, floors, roofs, external and internal garages. How well a home returns heat and thermal performance of a building is concerned with how well a home retains the heat. It's measured in terms of heat loss. It's commonly expressed, as we've just referred to in the slide before, as a U value, or it could be referred to as an R value. The more thermally efficient or insulated the fabric of the thermal envelope is, the less energy will be lost to outside, and therefore the less energy will be required to put back into the building to provide a comfortable environment for the occupants. Whatever the scale of retrofit, a technically sound and usually cost-effective approach is the one known as fabric first. It should always be considered when a retrofit plan is formulated, and that approach prioritises improvements in 5 stages, which we'll look at shortly. So let's take a look at heat loss. This illustration shows the government figures for the typical percentage of heat loss through a thermal envelope of an average domestic property. An energy performance certificate is designed to break these figures down for each property more accurately. Heat loss is the amount of heat energy that escapes from a building or a home, usually through doors, windows, floors, walls and a roof. Heat loss can occur by convection, where warm air leaks to the outside or cold air leaks into the house, or by conduction, where heat's transferred through the materials of the building. Heat loss affects the energy efficiency and heating costs of a building or a home. Heat loss can be calculated by summing the heat loss through all the surfaces of the building using an equation which would be heat loss equals area times the U value. Let's look at the fabric first approach of 5 stages, starting with stage 1. Stage 1 is about bringing the fabric into good repair, and that's by dealing with defects that inhibit energy efficiency and compromise improvement measures, dealing with water penetration and damp, dealing with structural defects, cracks or poor pointing of masonry. Stage 2 is about implementing the low-hanging fruit measures that are low cost and easy to install, such as energy efficient lighting, basic heating and hot water controls, or just better control settings. Stage 3 is about improving the building fabric in order to reduce heat losses and reduce the demand for heat and the required capacity of the heating system. That can be achieved by insulation measures, improvements in the air tightness of a building, and minimalising thermal bridging, or you may know them as cold spots. Stage 4 is about satisfying the remaining heat demand as efficiently as possible using efficient heating technology and responsive controls. And stage 5, finally, is about using low and zero carbon renewable energy technology to reduce emissions further and to top up the performance of the dwelling to the target level. Let's take a look now at an example of a whole house retrofit. This is a 5-minute video that was brought to us by the Aston Group, and it's a fantastic example of a whole house retrofit project from a fabric first approach starting point.
In 2019, the UK Parliament declared an environment and climate emergency, setting a target to bring the UK's greenhouse gas emissions to net zero by 2050. We all have a responsibility to be part of the change. Working together, we can help reduce carbon emissions. Currently, housing is responsible for around 20% of our greenhouse gas emissions. Therefore, it's key to identify ways to reduce this as we journey toward net zero. Part of the solution are energy-efficient new build properties. But we can't replace all our current housing with new builds, so we need to reduce carbon emissions in our existing homes. Retrofitting properties can reduce emissions from older buildings by introducing new, thermally efficient materials and modern, fuel-efficient technologies. Householders can gain a greater control of their homes, reducing energy loss, as well as making them more comfortable, healthy and affordable. Aston Group, alongside the London Borough of Waltham Forest, have been developing the first retrofit property in the borough. It's a 4-bedroom, end-of-terrace Victorian property and it had an EPC rating of E before we started work. Clearly, its energy inefficiency reflected its age. The challenge we set ourselves was to improve the EPC rating to a band A, while reducing the property's carbon usage by approximately 50 tonnes of CO2 over 30 years. Our first step was to survey the building. We carried out a number of efficiency tests, including air pressure and thermal imaging. This helped us identify exactly where the house was wasting energy and losing heat. Utilising a fabric-first approach, we looked at the core issues identified by our testing, using the data to begin resolving structural heat loss problems. We fitted a new, modern front door, ensuring a better fit and thermal performance. We installed smart ventilation bricks in the walls of the property. These bricks use algorithms that work alongside real-time weather information and air quality data to allow them to automatically adjust, maintaining a better living environment. We insulated the external walls, fixing a layer of rock wool, then covering it with a special render. It was essential to preserve the Victorian brick facade, so instead of using external insulation on the front of the property, we applied it internally. To reduce heat loss through the roof, we increased the thickness of the insulation in the loft of the property, ensuring it was in line with current building regulations. We applied underfloor insulation to suspended flooring. Using an innovative robot called Qbot, we were able to do this without needing to remove all the floorboards. We upgraded all windows in the property to low E-coated glass. This provides triple glaze performance in a double glazed solution. Once these steps were complete, we were ready to move on to installing the energy-efficient technology that heats and powers the house. We chose an air source heat pump as the preferred source of heat and hot water. It's more energy efficient than a standard gas boiler, extracting heat from the outside air to provide hot water for the home. It uses electricity to run and can extract heat from air temperatures as low as -15 degrees. We installed a mains pressure storage cylinder. The heating is delivered through radiators designed to work with the low operating temperatures of the heat pump. We fitted a mechanical ventilation heat recovery unit. This takes stale air from wet rooms, such as bathrooms and kitchens, and uses this to heat cool, fresh air as it's fed into the property. We fitted solar panels to the roof, along with a battery storage system, allowing any excess energy created by the panels to be stored and used at a later date. Further excess energy that can't be stored feeds into the national grid. We installed smart power sockets. They allow better management of energy demands, scheduling usage and controlling appliances remotely. Smart LED bulbs were installed throughout the house. They help reduce usage by enabling remote access and allowing lighting to be automated. A shower heat recovery system was installed. This uses residual heat from waste shower water to preheat the incoming cold water. Outside, we created an eco-friendly garden, introducing flowers and plants to help attract and sustain a healthy habitat for local wildlife. All of these changes come together to deliver a sustainable, modern and energy-efficient home. They showcase just some of the ways retrofitting a property can improve the environmental impact of our housing. The work undertaken on the property has successfully changed its EPC rating. Before the house was a Band E, it's now a Band A, substantially reducing the property's energy use and carbon emissions. Whole house retrofitting will play a huge role in how we deliver low-carbon homes across the UK. Every single retrofit property we can create will play a role in lowering our household emissions, helping drive us towards our goal of net zero.